Hello, everybody, and welcome to MME 2305, Material and Energy Balances. Today, we are going to be talking a bit more about balancing equation. Here, we have a chemical vapor deposition chamber. So this is a scenario that one might encounter in a semiconductor fabrication facility, something very near and dear to my heart. We have a situation here where we're coating a substrate with tungsten carbide. We want to think of this in terms of input and output. Okay, so here we have our inputs, which are our gases, so WF6, C6H6, and H2. We have an output of HF gas. Excuse me, I was trying to annotate there. And we want to coat our substrate with tungsten carbide, so this would be a reactive material balance. Just kind of go over a kind of a quick review. So we have steps for balancing equations in this class, and we have a whole other video where we talk about balancing equations in this class using the refining of copper. But again, just kind of go over it again. Step one, we write an unbalanced equation. Step two, we assign variables to this unbalanced equation. So our reactants, we assign the variables x, y, and z. And our products, we assign variables A and B. You can find other variables. Do caution that sometimes you don't want to get your variables confused with the elements. For each element, we want to write an equation to describe an elemental balance based on the variables. So in this case, tungsten, if we look at the stoichiometry, we have WF6 and W2C. So here, X equals 2A because W2C has two tungstens in it. Step four, we want to assume a basis for our elemental balance. So in this case, A equals 1. So if A equals 1, X equals 2, and Y equals 1 over 6, and so on. And then we write our semi-balanced equation, and then we want to get rid of the fractions. So we want to balance the equation based on whole number values. So now we can do some mass balances. What we have here, we have a problem that's asking if we want 500 grams of W2C, or tungsten carbide, what mass of tungsten hexafluoride do we need? And so if you remember, we set up our elemental balances for our variables, so it actually becomes very, very simple. So we want to look at this. So the first thing we got to think about is what basis do we want? So if we want 500 grams of W2C, what mass of tungsten hexafluoride is needed? So what is our basis here? Let's think about it. Okay, we thought about it. Our basis here is 500 grams of tungsten carbide. What do we know about this? Well, we know that 1 gram mole of tungsten carbide is equal to 379.69 grams of tungsten carbide. Why are we thinking of things in terms of moles? Okay, why are we thinking of things in terms of moles? Well, if you go back to our chemical equation, that relationship, this 12 WF6 or 12 tungsten hexafluoride to 6 tungsten carbide is a 2-to-1 ratio, but it's a 2-to-1 molar ratio. Okay, so we want to think of things in terms of moles or convert things from mass to moles so we can figure out what quantities we need. So the question is, if we want 500 grams of tungsten carbide, what mass of tungsten hexafluoride is needed? So our basis is 500 grams. We know the molecular weight of tungsten carbide, so it's 379.69 grams. We can find that off of our handy-dandy periodic table. We now know that we have 1.32 gram moles of tungsten 2 carbide. Okay, and so we assign that variable A. Okay, so let's go back. So here, X equals 2A for tungsten. We want to know how much tungsten hexafluoride is needed. Well, that's quite simple now. So X equals 2A, based on our algebraic relationship we came up with when we were balancing the equation. So that equals 2 times 132.6 gram moles of tungsten carbide. So we now know we need 2.64 gram moles of tungsten hexafluoride. Got to pay attention though. The question asks what mass of tungsten hexafluoride is needed. Well, that's very simple. We're excellent at this by now in this class. We know that 2.64 gram moles of tungsten hexafluoride, based on the molecular weight of 297.78 grams per 1 gram mole of tungsten hexafluoride, equals 786.13 grams of tungsten hexafluoride. So we've answered the question. We now know what mass of tungsten hexafluoride is needed. Thank you very much for your time. If you have any questions, feel free to ask me in class or shoot me an email. And good luck in your material and energy balances.
Oh my. It's the end of the lecture. If you have any questions, you can email me at drobertson@utep.